Konstantin. If you check out the schedule, then I'm supposed to talk about message in a bottle, but I'm not going to do that now. If you want to see that talk, I gave a talk about that topic at last year's RubyConf, and it's up on Confreaks. So feel free to watch it, maybe not right now, or at least go outside. Instead, and you'll see why I'm talking about something else. Instead, I'll be talking about something concerning pull requests. But first of all, for those who don't know me, I work on some open source projects. This is supposed to be a hat. I'm probably most well known for being the maintainer of Sinatra, which hopefully at least some of you know what that is. And I also wrote a book about Sinatra, and here's your one-time chance to get it for a 50% discount at O'Reilly. Rumor has it that that discount code also works for other books. Yeah. I also have small cards with it on. You don't have to write it down right now, but feel free to. And at the moment, I work at a company called Travis. We do continuous integration in the cloud for free for open source projects, and it is an open source project. And we recently got a big round of crowdfunding. Josh will talk about this more tomorrow. And I just want to thank our sponsors, especially Cloud Control, Wooga, Bandyworks, and Xing, who are making all this possible. And as you might notice, I also wear the corporate identity outfit of Travis, which consists of a shite shirt and a mustache. And yes, I've just been grown this for this talk. Okay, so pull requests. Pull requests are pretty cool. Who in here has never used GitHub pull requests? I don't see a single hand. Oh, it's not a shame. Okay, so who in here has used pull requests? Okay, cool. Pull requests are, in my opinion, the single coolest feature that GitHub has to offer. And, you know, it looks like this. You probably all have seen that. You get a pull request from someone, and now it looks good, and you want to merge it in. And a while back, what you had to do is you had to manually merge it in. That means you could either, if you can't read that, it's fine. That's the help you get if you press the help button on the pull request page. So you could either merge it in, like properly clone the branch, or there were some features that back then were not really documented, like you could add patch to the URL of the pull request and pipe that through git.am, which is what I did. And that's all a clean way to do it, but it's a bit tedious. You have to do it all locally, even though you have this cool pull request there. And then GitHub decided to pimp that up and added, so no, I'm sorry. The workflow was, as I just described, all locally. And then you check it if it works. And then if it works, you can push it back upstream, and if not, you just discard it, add a comment to the pull request and say, oh no, this stuff is broken, can you please fix this? Or go away, whatever your response would be. But then GitHub decided to pimp that up and added the merge button. Yeah, I'm sorry, this is super small. There's merge pull request, which would merge it in the web interface, which is super cool because it would mean you can, while you're sitting on a tram and a pull request is coming in, you can look at it on your iPhone, press the merge button, and done. But there's an issue with that. The workflow now looks like this. You have a pull request coming in, then you hit the merge button, then hopefully your CI will run and tell you whether everything's still fine or something broke with the commits that you just merged in. And then you sit there and don't know what to do. I hear José likes to do that with Rails and then revert the commits, which is kind of not that nice because it's extra work, it's those revert commits and so on. And that led to the idea of, if it's not documentation, then don't press the merge button. Do it locally again, go through it, yeah. And this is where I have an announcement to make. We are going to fix that. Nay, we have fixed it. And the rollout of the fix will start today. We will enable it on a per project basis. I'll explain why we won't enable it for every project right away. In fact, we have enabled it already for Rails, for Ember.js, for Sinatra, and for some of the Travis projects. And if you want your project enabled, talk to us. We give priority to people that donated to our crowdfunding campaign, especially those that donated a bit more. But if you think your project should be on the early rollout, just talk to us or just wait a few weeks. And this is what the new workflow looks like. A pull request is coming in. You look at the pull request. You magically know if it passes on CI or not. And then if it passes, you can press the merge button. If not, well, just not and enjoy the rest of the day without having to worry about it. And this is what it looks like at the moment. We have a GitHub bot account that will go to the pull request and add a comment to it and say whether the merged version, not the version of the that is in the fork, but the merged version will still pass all tests. And then once you see this, well, we have pimped that up, or we're playing with adding images so you don't have to really read the words. It's still, we're still figuring out what the best to do. There are also ideas of having two bots, one with a red avatar and one with a green one. We're still not decided on that.
It's too much to read.
Yeah, I know. Reading all those 4 words. And then you can just merge in the pull request. Or you can merge in the broken pull request if you feel like it. But how did we do that? When I first started working on this feature, I thought it was pretty simple, but then it turned out I worked weeks and weeks and weeks, and we kept announcing, yeah, in 2 weeks we're done. 2 weeks later, in 2 weeks we're done. And now we're done. And what happens is we take the pull request from the API and try to figure out what we have to test. This is, if you go to the repos pull request, you get a nice JSON response with a lot of things you actually do not need when you want to do this. So the main issue is that we don't have a concept of 2 repos, and we don't want to monitor the second. The second one might even be a private repo, whatever. And we want to now figure out how to get the merged commit. Because what GitHub does is they actually create a merge commit, and then, based on a merge commit, decide whether it's mergeable or not. So the question is, can we use that? So we took a look at the API representation of the pull request. Turns out there's actually nothing in there that could help us. What a shame. But after playing around and actually asking people at GitHub, turned out that they actually create a Git reference for their merge commit. And you can get that by asking for the pull request references. The first 3 dots would be your repository. The last 3 dots would be your pull request number. And what you find there is a head commit. The upper one is the head commit with the API URL to request it. And the lower one is what is called the merge commit. And if you check this merge commit out over the API, then it seems a bit curious. The committer of this merge commit is actually a user called GitHub merge button. First time I saw this, I thought, wait, no, what's happening? But if you check the commit out, actually for every pull request that's mergeable, in every repository, it may be Rails or whatever, there are those merge commits. You just don't see them because you don't clone the references. And they're made by GitHub merge buttons. So if you know the commit SHA, you can take a look at them. If you don't know them, you can check them out with the references. You need a bit of Git food to do that, because those references, so a reference is usually either a branch or a tag. It's basically naming a commit. But those references are neither a branch nor a tag. That's something just GitHub added to the repositories because they feel like it. No, because they use it internally. And that way, we only need the repository the pull request is going into. And that repository we definitely have access to. This isn't, it's not that important for open source projects, but we are also working on adding private builds, and it might be that we do not have read access to the repository, to the fork repository, and this way we do not have to care about the fork repository. Especially in the workers, there's no logic saying this is where the fork came from. Instead, all we have to do is, once the worker is done, instead of sending out emails and IRC notifications and so on, we just have to use the GitHub bot and comment on the pull request. If you would want to try this at home, here's how we do that. Just go to your repository, do a git fetch origin with that magic syntax to check out a ref that is neither branch nor tag. Then, because you could also use the SHA-1 sum here, but you can also use the fetch head, which is the head of your latest fetch. And then you're at the commit. And you can feel great for having a commit from GitHub merge button in your local checkout. So if we want to add that to Travis, we have to add it to this architecture. Travis is a distributed application. That means we have different independently moving parts that are loosely connected through a database, through a queue, and through SSH. And we have the CI part that's mainly called CI for a historical reason, which is basically the web front end. It's called CI because at the beginning, Travis was one big application, one big Rails application. And that's just for helping you set up hooks and just for looking at the build status and so on. It's what you see when you go to travisci.org. And then we also have the hub, which is responsible for taking in incoming events, like someone pushed to GitHub, then the hub will be notified. Not directly, but the hub will actually decide what to do with that push and queue it for the worker to use. And the worker will then start up a virtual machine, run the tests, kill that virtual machine, and respond with the results back to the hub, which actually then sends out push notifications so you get those live updates in the web interface. The hub is also responsible for sending out emails and etc., etc. And then we have a small app that's the listener. The listener is actually just a Sinatra app that does nothing but wait for messages sent from GitHub. And the reason this is not part of the hub or CI is that we can actually take the complete system offline, except for AMQP, and the listener will still work. It will still enqueue the messages coming in from GitHub in AMQP, and once hub boots back up, can take the messages and decide what to do with that. That way we do not lose your push, even though we have some maintenance issues or updating our systems. We do not lose pull requests because of that. And the path a pull request would take through this would look kind of like this. The user or someone opens the pull request on GitHub or updates the pull request for that matter. Then GitHub sends an event to the listener. The listener will queue that. Well, actually, it would have to go to the hub and back at that point. I simplified that a bit. The hub would then decide if to process this and which queue to have that ended up, which is basically at the moment based on the programming language it's in. And then would go through the worker and back, and the hub would send out the GitHub message. And dependency-wise, we have a lot of logic encapsulated in a library called Travis Core. So if you go to the Travis CI GitHub user account, there's Travis CI, Travis Hub, Travis Core, etc., etc. And the logic for dealing with pull requests is mainly in Travis Core, which is used by both the CI and the hub. And Travis Core in turn is using a library called GH, which we created just for this, which is then using Faraday to talk to GitHub. Faraday is a really nice little library by one of the GitHub guys, Technowini, for dealing with HTTP APIs and so on. And you might be wondering, yet another GitHub library? So the story is, we used to have something written ourselves really, really simple. And then in addition to that, OctoKit. When I started working on pull requests, I started modifying what we had, but then it turned out that wouldn't work and started a third one. And then it turned out that one was doing way too much in one place, so I started GH. So in the life cycle of pull requests, we were using 4 different GitHub libraries at the same time. We are now down to 2. We're using OctoKit and GH, and we're looking into whether we should get rid of OctoKit. And the reason is that we actually wanted just a thin wrapper. We didn't want to have any magic going on, but we also didn't want to care about a lot of stuff, like when to send out HTTP requests and so on. This would look like a bit like this. Travis Hub would call into Travis Core. Travis Core would then go to GH, and that library would decide how to query GitHub best. And we were following a middleware approach. You might know from Rack or from Faraday, where you can just say, oh, use this middleware and then use that middleware, and it will basically build up a recursive stack going down. And at the bottom of the middleware, you will have the actual endpoint, which in our case would send out requests to GitHub. And what really matters in this stack are those 4. This is what we were kind of missing from the existing GitHub libraries. The normalizer is currently a layer where we adjust the GitHub API on the rough edges. There are rough edges. For instance, sometimes the user has a name field that is actually the login, whereas user also has a name field, which is the username and so on, which we have to deal with. And GitHub will probably adjust that. GitHub is really quick in adjusting whatever issues we have with the API, and has actually added API just for us a couple of times. And the most important thing for us is the merge commit layer, which will actually resolve the merge commit. The library is used can be used like this. You instantiate the default stack, which uses all the middleware I just showed you, and then you can query it. It will just be arrays and hashes you get back. You can also, one other feature we needed was scoping without having to hand on the object all the time. Otherwise, we would have handed on the GH instance all over Travis, which would have been annoying and a major change. So we have this singleton method on the GH module, where you can just query it and we'll use the default stack. And that alone wouldn't be useful, because that would be just like having it in a global constant. But what you can actually do is scope that GH constant. And the use case we have for that is authentication. So we can have some part that just describes the GitHub interaction without having to care whether you're logged in right now, etc., etc. And then when you call out to that code, you can just wrap it in a gh.with, pass in an OAuth token or username and password, etc., which is also how we remote control the GitHub bot. And then one last feature, which was really important to us, is that we can take a payload from GitHub and then just say, run it through the middleware stack. So we have all the features added to it without actually having to query GitHub, which we use for the service hooks we get from GitHub. And then we can just ask it for the merge commit, like that. And GH makes extensive use of hypermedia. And it sounds fancy, but what we do is actually simple. If you get a payload from GitHub, it often has this links hash in there with references. And what we do with that, for one, is if you access a field, like say there's a link called comments on pull request, and then if you access the comments field in the hash GH returns you, we will lazily, so only if you access it, we will query it from GitHub and give you the response as if it was nested in there, and it is in fact nested in there from that point. And one other thing is we also load fields. So if the field is not a link, but it's missing, and there's a self link, we actually load it from the self link, which is really useful. So every hypermedia document has a self link, which is basically really useful if you, for instance, have the pull request and there's a user, but you don't have that much information about the user, just to log in and the self link. But what you actually want to have is the email address. Then if you ask for that, we'll use the self link to figure out what the email address is. Oh, and one more thing. Getting back to pull requests. This is what a pull request event looks like. The action says what actually happened to the pull request. This could be opened, closed, synchronized, comment added, whatever. And what we care for is the open event and the synchronized event. The synchronized event means that either the base, which is the repository it was forked from, has changed, or the head has changed, which is the repository sending the pull request. Now, if the head has changed, we obviously want to test again, because probably a commit has been added, like it broke, and then the committer just fixed the issue, and then we should test it again, otherwise he would have to open, or she would have to open another pull request. But we don't want to have it triggered every time the base is updated. Just imagine you're maintaining a large open source project like Rails, and you just add one commit to master. You have 400 pull requests open. All of a sudden, all those 400 pull requests are tested in all the configurations on Travis. Then the queue is just jammed, and the next push will be tested in a few hours, however fast it is. And that's something we want to avoid, because that would actually render Travis CI useless. So what we do is we detect what of the two changed and only do it on a head change. Now we think that's not ideal for every case, so we were considering maybe for private builds allowing both, because someone could add a pull request with a failing test, and in the meantime the bug is actually fixed on master. We could detect that. We're also considering whether we should put a link where you can trigger it again or something like that. We're still at the point where we're figuring out where to go with that. And yeah, I actually wanted to demo it live right now, but apparently there are some issues. GitHub is not sending out pull request events.
You can do it with Travis Core.
Okay.
And I've deployed changes to master.
Okay. So let's see. How am I time-wise? How am I time-wise?
I think you should be starting Q&A.
Okay, yeah. So there are commits already you can check out. It's working on Travis Core for some reason. We'll have to sit down with the GitHub guys and figure out what the issue is. But if you go down, then there's a comment on live that's on our live system, just enabled for Travis Core, and it works. Thanks. So, questions?
So actually I have a question about what kind of stack capabilities are going to be in the Travis CI. If customers are going to be able to run very specific stacks, like for example testing Flex applications over the Travis CI, where Flex is required very weird binaries that are hard to deploy.
So your question was more about Travis and not about pull requests, if I get that right.
Yes, that's correct.
And you wanted to know what kind of applications are testable on Travis. So basically, all applications that you can usually test on, say, Jenkins or whatever. The limitation is that at the moment we only offer Linux. We have full root access, so you could install anything. And we are looking into how we could, for private builds, offer pre-built VMs. But basically, everything you can start in VirtualBox and SSH into, or everything you can start somewhere in SSH into, we can test. So, yeah. Did that answer your question, or? Okay. Okay, more questions? Okay, then, thank you.